Welcome everybody to this exercise class where I would like to talk about the total differential. I'll show how the total differential is calculated, and I would like to highlight some applications. What is a setting? In an office building, employees use the elevator to move up and down. The weight of a woman is 50 kilograms and the weight of the man is 100 kilograms. Your tasks are as follows. In the first step, create a graph in which the number of men is characterized on the horizontal axis and the number of women is marked on the vertical axis. You should draw a curve in this diagram which symbolizes a total weight of 1000 kilograms. And in the second step, please calculate the slope of the curve by using the total differential of this equation. In this equation, we have the weight of the man times the number of men plus the weight of the woman times the number of women. This gives the total value of the weight. Okay, in the first step, we have to create this kind of diagram, and then when we look at the maximum number of women which can take this elevator, we have to divide the total weight of 1000 by the weight of a woman, which is equal to 50. So we get 20 women are able to use this elevator in case that the number of men are equal to 0. We wanted to put the number of women on the vertical axis and the number of men on the horizontal axis. In case that the number of men is equal to 0, then 20 women could board this elevator. In case that there are no women at all in the elevator, then 1000 divided by 100, 10 men would be able to board this elevator. And when we combine these two dots by a straight line, then we get all the combinations of men and women, which leads to a total weight of 1000 kilograms. What about the slope of this curve? When you go from one dot, like one step to the right, the curve goes like 2 steps down. So that the slope of this curve is given by df over dm. df is equal to -2, dm is equal to +1. So the slope is equal to a -2. In case that you cannot remember anymore whether it is df or df divided by dm or dm over df, please have a look at the following slide. Here you get the following donkey bridge, the following Eselsbrücke. Like in a diagram, we have one variable on top and one variable on the bottom. And in case that we want to derive the slope of one curve, we have to build d top, d bottom. In the numerator, we have d top, and in the lower part of the fraction in the denominator, we have d bottom. So we always have to check what kind of variables are displayed on the vertical axis and the horizontal axis, and then take this differential here. Yeah, let's come up with the total differential. This is the equation, and then we write a d in front of the left-hand side. And when we differentiate with respect to the first variable on the right-hand side, what is left is m. So when we differentiate with respect to the weight of man, what is left is the number of men. So this part is the number of men m times we differentiate it with respect to the weight of man. Let's differentiate with respect to the second variable. When we differentiate with respect to this m here, what is left is the weight of man. So, like we have to add gm times dm, we indicate by this dm that we were differentiating with respect to this second variable. When we differentiate with respect to the third variable, then what is left over is f. So the third part is f times dgf. And when we differentiate with respect to the last variable, when we differentiate with respect to f, what is left is gf. So the last term is gf times df. This total differential here in equation 3 can be interpreted in the following way. The total weight will change, so dgg is not equal to 0 in case that the weight of the man changes, in case that the number of men changes, in case that the weight of the women change, or in case that the number of women changes. In the following, I would like to use this total differential to compute the slope of this curve. Therefore, we have to come up with some assumptions. The assumptions are, along the curve, the weight of the women and the weight of the men are constant. Thus, the weight of the women and the weight of the man do not change, and the changes are equal to 0. Furthermore, the total weight does not change, and therefore the change of the total weight is also equal to 0. In equation 5, I highlighted in red ink those elements of the total differential which are equal to 0. When we set this part equal to 0, we arrive at equation number 6. Now we have to compute the slope of this curve by computing df over dm. So in the first step, we put this one on the left-hand side of this equation. So we subtract gf times df, and this pops up on the left-hand side with a negative sign. Then we divide by minus gf again. We get to equation 8. df is equal to minus gm over gf times dm. And then we divide by dm, and we have computed the slope of this curve. The slope of this curve is negative because there is a negative sign in front of this fraction. Let's plug in the numbers for the weight of the men and the weight of the females. So it's 100 over 50. So the curve has a negative slope of minus 2 units. And this has to be interpreted in the following way. If one additional man enters the elevator, then under all other conditions being constant, we call it ceteris paribus, 2 women have to leave the elevator so that the total weight remains constant.
Come on, let's do it. Let's do it.
Oh my
Ready? Ready?
No. Don't that much, Jeremy.
So we have characterized the slope of this curve. Let's have a look at one equilibrium, and then we'll shock this equilibrium. We assume that the maximum total weight is equal to 1000 kilogram. So this is the capacity constraint of the elevator. In the first step, m is equal to 5 and f is equal to 10. So 5 men, 10 women are in the elevator. And it is the case that the elevator operates at the capacity constraint. We can prove that by computing weight of men times number of men plus weight of the females times the number of females, and this is equal to 1000, so the elevator is operating at the capacity constraint. And now we assume that 4 more women enter the elevator, that df is equal to plus 4. The second task is argue on the basis of the equilibrium condition which adjustments principally could take place, distinguish what kind of possibilities exist in the short run or in the long run. You should calculate on the basis of the total differential how much the respective variable has to change. Our assignment should stay realistic. No person may weigh less than 50 kilogram, and therefore a reduction in the weight of the women is impossible. Let's have a look at what happens after the shock occurred. After this shock occurred and the females tried to enter the elevator, the total weight is larger than the capacity constraint, and therefore in the short run it is the case that the number of men has to be reduced. The number of men must decrease, and hence some men have to leave the elevator. In the long term, of course, it is also possible that the men have to be on a diet or the women have to be on a diet. We do not look at this idea at all. And then the third possibility is that in the long run also stronger ropes can be installed so that the capacity constraint is increased. You can see the adjustment possibilities in the long run indicated by the green arrows. When more females are in the elevator, we can reduce the weight of the man, the weight of the females, or we can increase the capacity constraint so that these 4 additional women can use the elevator. In the short run, of course, only the man can leave the elevator. Only just adjustment process is possible. Therefore, in our total differential, we can set some terms equal to 0. Like those terms which are equal to 0 are once more highlighted in red ink. In the short run, we cannot change the capacity constraint. We cannot change the weight of the man or the weight of the woman. This will take time. Therefore, these red elements are equal to 0 and we get to equation 14. Overall, we want to compute the relationship dm over df. So let's put once more gm dm on the other hand side of the equation, pops up with a negative sign here. We divide by minus gm, put that on the other hand side. We arrive at equation 16. Then we put df on the other hand side of the equation. And then we get to this expression here, dm over df is equal to minus gf over gm. So this term has a negative sign. So in case that df is positive, then dm has to be negative. If the number of women in the elevator increases, then the number of men has to decrease. Let's plug in the numbers. The weight of a female is 50, the weight of a male is 100, so the overall expression is equal to minus 0.5, and this has to be interpreted in the following way. If one woman gets into this elevator, then half of a man has to leave the elevator, but in this task 4 more women are joining the elevator. Therefore, we have to put this df on the other hand side of the equation. And then we get to the following insight that once more we are plugging in the information we have. df is equal to plus 4. And when df is equal to plus 4, then dm has to be equal to minus 2. So if 4 women are getting into the elevator additionally, then 2 men have to leave. We can also have a look at the graph. Like in the initial equilibrium, 10 females and 5 males were in the elevator. And then it is the case that 4 additional women show up. The capacity constraint is not met anymore, but 2 men have to leave the elevator so that the capacity constraint is once more met. In the end, there will be 14 females and like 3 males in the elevator. So this was the solution in the short run. Let's have a look at the longer term. In the longer term, we can put thicker ropes in the elevator so that the capacity constraint increases. The number of men will be constant. The number of men does not change. dm is equal to 0. Also, the weight of men and the weight of women will be constant so that these terms are equal to 0. We get to equation 19. We can put df on the other hand side of the equation and we arrive at equation number 20. In equation number 20, there is a positive sign, and this implies that if df is positive, then the variable dgg must also be positive. It implies that when some additional women are entering the elevator, then the capacity has to be adjusted upwards because of the fact that the total weight increases. By how much does the total weight increase? In case that only one woman arrives, then the weight increases by 50 kilograms. But in our example, it is the case that 4 more women are boarding the elevator. Therefore, we have to put df on the other hand side of the equation, and we get the information that the capacity has to be increased by 200 kilograms. We can also highlight this solution in a graph. So the blue solution is a solution where initially we have 10 females and 5 males in the elevator. The capacity constraint is at the level of 1000, and when the capacity constraint is at the level of 1200, because there are thicker ropes in the elevator, then this capacity constraint shifts to the right or upwards, and it is the case that 4 additional women are able to board this elevator. Another adjustment possibility is, of course, thinner men. Put the man on a diet. Then it will be the case that we are not doing anything with the ropes, so the capacity constraint will stay constant. The total weight does not change. The number of men will stay constant, and the weight of the females stay constant. But what is changing is, like here, the weight of the man. This is the adjustment due to the fact that some women are additionally entering the elevator. The red parts are equal to 0, and we have to solve for the relationship dgm-df. So in the first step, we put this term here on the left-hand side, pops up with a negative sign. We put minus m on the other hand side of the equation, and in the end, we divide by df. So we get this expression here, which can be interpreted in the following way. The negative sign implies that if df is positive, then dgm has to be negative. Like when the number of women in the elevator increases, then the men have to lose weight. If one woman gets in, the man must lose like 10 kilograms. This stems from the numerical example. In our task, however, it is the case that 4 more women join in, and then we have to put like this df on the other hand side of the equation. We get to this relationship here, and then we get the result that dgm is equal to minus 40. So if 4 additional women are joining the elevator, each of the 5 men has to lose 40 kilograms. This makes sense because the 4 women, they have a weight of 50 kilograms each. So the total weight increases by 200 kilograms, and hence 5 men have to lose 40 kilograms so that the elevator still operates at the capacity constraint. We can also have a look at the graph. The blue line once more is the initial equilibrium, red dot 10 females and 5 males. And now we put the males on the diet. It is the case when there are no men in the elevator The curve still starts at the level of 20 because still only 20 females are able to board this elevator. But what if the number of females would be equal to 0? Then 1000 divided by the new weight of man, 1000 divided by 60, is equal to 16.7. So we have once more two dots, this one here and the one over there. We can connect these two dots and we get to the orange line. Then we can also see that now the capacity constraint in the new equilibrium is met. So when 14 females are in the elevator with a weight of 50 kilograms and 5 males are in the elevator with the weight of 60 kilograms, then we are once more at the capacity constraint of 1000 kilograms. Let's have a look at the third part of the exercise. In the third part, we assume that thicker ropes are installed and the maximum total weight increases to the level of 1500 kilograms. Analyze the new situation graphically. Use the initial graphic to work out how much the curve has to shift horizontally or vertically. Afterwards, you should use the total differential in order to calculate by how many units does the equilibrium curve shift horizontally. Horizontally means to the right or to the left. And then you should also find out by using the total differential how many units does the equilibrium curve shift vertically, so up or down. In the graph, this is as follows, like blue, the initial situation where the total weight is equal to 1000, and when the weight is increased to the level of 1500, in case that the capacity constraint is at the level of 1500, then at max 30 women or 15 males are able to board the elevator. So what about the horizontal shift? The curve seems to shift like 5 units to the right. This implies that when we are in this situation here, where 12 females and 4 males are in the elevator, like 5 additional males would be able to use this elevator in case that the number of females is constant. So dm is equal to plus 5, the curve shifts 5 units to the right. Or we could look at the vertical shift. df is equal to plus 10, with thicker ropes, like 10 additional females would be able to board this elevator. Let's also perform the calculations. We want to talk about the horizontal shift first, and on the horizontal axis, there we have the number of men, and we know already from the graph that dm is equal to plus 5. So on the horizontal axis, we have the variable number of men, and thus we have to compute the expression dm over dgg. And then we can find out how many numbers of men can board the elevator additionally in case that the capacity constraint was increased. So it is a case that the number of men will change and the capacity constraint changed, but it is a case that the weight of the males, the weight of the females, and the number of females is constant. Once more, we can check that in the graph. When we shift this dot 5 units to the right, the number of females does not change. The number of females stays constant at the level of 12. Therefore, df is equal to 0. When we set all these red expressions equal to 0, we get to equation number 29. Now we have to solve for dm over dgg. So we put DGG on the other hand side of the equation, then we put the weight of the man on the other hand side of the equation, and we get to this relationship here. When we plug in the numbers we have, we learn that there is a positive sign. In case that thicker ropes are installed, then it is the case that the number of men has to increase so that the elevator operates at the capacity limit. So in case that there are thicker ropes and the capacity constraint increases, then more men are allowed to board. How do we have to interpret this number? If the capacity constraint increases by 1 kilogram, then the number of men increases by 1/100. In our task, the capacity constraint increased by 500 kilograms, and therefore we once more have to put this DGG on the other hand side of the equation and insert the 500 kilograms for this term. So we get the answer that dm is equal to 5 in this situation. In case that the capacity constraints increases by 500 units, then 5 men are able to board this elevator. The vertical shift, there we have to check what kind of variable is displayed on the vertical axis. It is the number of women, and therefore we have to derive this expression here. The capacity constraint changes, also the number of females will change, but the weight of the men's and the weight of the women, this is constant. The weight does not change. The change in the weight is equal to 0. Also, it is a case that the number of men is constant. So when this dot shifts upwards, it is the case that the number of men is equal to 4 in this dot and that dot. The number of men does not change. Therefore, the red elements are equal to 0. We arrive at equation 33. Then we have to solve for df dgg. So we put dgg on the other hand side of the equation. We put gf on the other hand side of the equation. And then we can come up with an interpretation of this relationship. The positive sign indicates when thicker ropes are installed and when the capacity constraint is shifted upwards, then more women can board. By how much? In case that the capacity constraint increases by 1 kilogram, then 1/50 additional women are able to board the elevator. And in this task, the capacity constraint increased by 500 kilograms, so that it is the case that we once more have to put DGG on the other hand side of the equation. In the end, we get the answer that df is equal to 10. And this has to be interpreted in the following way. The total weight is increased by 500 kilograms, and therefore 10 additional women are able to use the elevator. This is the end of this assignment, and now the doors of the elevator will open and you are released to the freedom.